video lecture with guidelines for developing queries. Right? We've been learning SQL. You can see from some of the advanced examples that SQL can get very complicated, very. Developing queries, some of the tips the author has proposed that I agree with wholeheartedly. First, familiar with the data model. Learn your table. I say this to students all the time that if you're going to go for a job and you're going to do entry-level SQL work, likely you'll be amongst at least 3 people that they're going to take on for the same job. And what they do is they see how you work, they see how fast you learn, they see your SQL skills and your style, and they will eventually probably only hire one of the 3. So, my suggestion is to always put in the extra time. If you've got the job, so you've got the seat, what you want to do is spend a little extra time after work, if you can, on a daily basis, learning their data, learning tables. You can know all the SQL, you can have all the SQL skills in the world, but until you know the data that you're working with, you are useless. So, you have to make yourself as useful as possible, so that means becoming familiar with the data models. Enough said with that. Another tip would be understand what the desired results are. This can get very, very tricky. This is one of those soft skills when it really becomes interpersonal. Reading someone, trying to figure out exactly what someone is talking about. For instance, here at Hofstra, someone comes to me and says, "Mike, I need a list of all of the students." Well, all of the students is a large data set. Is this person talking about just the undergraduate population? Is this person just talking about registered students? Is this person just talking about enrolled students? What does the word students mean to that person? You really need to dig through and take your time and interview the person who's asking you for a data set, because you need to understand what their desired results are so that you can get it to them. That goes along with know the attributes desired in the result. Do you want to see last names and first names? Do you want to see just identification numbers? Do you need their email address? Do you need their phone numbers? What does this person need to fulfill all of their needs? And then you need to know the data. You need to figure out which entities you have to join together to get this person their data. If need be, review the ERD. In an Access database, that's the relationships window. But some organizations actually keep handy the ERD. I refer to the ERD associated with the Banner system here at Hofstra quite often. I construct where clauses for each link, although my preference, of course, is the one thing that I disagree with. I prefer the join notation. I think the author is just, a little in the past with using where clauses to link tables together. If you can, fine-tune your group by and your having clauses so that you're only returning, again, what the customer wants. Consider the effects of unusual data. For instance, if you need to sort things on dates of birth, and the dates of birth are stored as text, and there's some text in there that isn't in a date format. You have to consider that and to see if some records are going to get removed from the end data set because of that. Then we talk about efficiency. Remember, we want to write efficient SQL. We don't want to write an SQL query and get a result set that's going to take 5 minutes to run. So, in a lot of the labs, I'm asking you for just, give me all the data, because I know you know how to write select clauses. So, in reality, you really want to specifically pick just the attributes that you want, so don't use select star. Limit the number of subqueries. Some subqueries can be inefficient depending on how you write them. So the idea would be to try to do everything in a single query. And again, that's only if possible. And if you're going to reuse the result set over and over and over again, say for over the span of 10-15 minutes as you run different reports, Well, do a materialized view. So you're actually storing the result set so that all of the reports will actually run immediately. Know how indexes are used, right? So again, that kind of gets back to knowing your data. Know that if this company, know whether or not this company has developed an index when it comes to sorting your data. We really didn't get into the optimizer, but all database management systems have an optimizer that use statistics in the database. For instance, for eye color, is the eye color blue more often listed than any other color? How is the data skewed? That kind of stuff. So the optimizer keeps statistics on that, and it uses that to optimize your SQL. So believe it or not, whatever kind of SQL you submit to a database management system, the database management system typically rewrites it for you in the background to make it more efficient. And if you use a tool like Toad or something, you can see how it'll rewrite it hundreds of times until it finds the very best one. Use compatible data types for fields and literals. So if you're going to slip in a string literal here or there, you want to make sure it's a compatible data type with the other fields. Keep your queries simple. There's a pretty good tip, guideline. Break complex queries into multiple simple parts, which kind of goes against having a bunch of subqueries, but hey, it depends on the scenario. And then don't nest one query inside of another. So those two kind of offset each other. It really depends on the scenario. Don't combine a query with itself. If possible, avoid self joins, which we know how to do and we used with the employee table. You want to create temporary tables or materialize your views. You want to combine any update operations so that it all happens in one transaction rather than running query after query after query. Again, only retrieve the data that you need. Some of that has to do with most of the time your database is not on the same machine that you're working on. So when you're retrieving data, it causes network traffic. And we'll talk more about that in other chapters as well. But remember, whenever you ask for data, that data has to travel over the network. So realize that you are causing network traffic. Keep learning. Don't ever stop learning. I learn something new, I would almost say, on a daily basis. So keep yourself current and keep learning. And then analyze query processing time so you can reduce it. Again, that's easier to do when you have a tool such as Toad that will help you optimize your queries. So that is the end of the video lecture on tips and guidelines for better query design. And now we are pretty much done with SQL.